Good evening. This is, this is Mr. Morrissey. I hope everyone's having a great day. Um, so we're looking at factoring quadratics. Our objective is to factor a quadratic expression to reveal the zeros of the function it defines. I want you to read this sheet. I'm going to point out a couple things I think are important, and I'm going to be calm. I'm going to write clearly. I'm going to model effective, exemplary solutions, and I'm going to do my best here to review factoring. Factoring basically means if you take an equation like here an x squared plus 9x minus 36, and you break it into terms. So it says here to factor is to break an expression into factors, which means to write the expression as a product of different terms. So the factors in this equation that I just highlighted would be x minus 3 times x plus 2. We'll be doing a bit of foiling, or sometimes I like saying expanding. And yeah, so we're going to be doing a lot of factoring. And I think it's going to be things that you are vaguely familiar with. There's some vocabulary here. Monomial. Monomial is like 2x, and a binomial is like x plus 2. A trinomial, like the tricycle my daughter is trying to ride, has 3 parts to it. The standard form we did in our last set of notes, the ax squared plus bx plus c. This thing about the product and sum of zeros we'll do in class. There's some shortcuts around that. Difference of squares is something that will come up in your math classes that are, I would say, like essential to know. For example, on the SATs, if you're asked x squared minus 1, you know you can factor that into x plus 1, x minus 1. And making sure you know the classic trap in math in high school. For example, if you were to think that x minus 1 squared equals x squared plus 1, trap. You don't want to be caught in that trap. Biggest trap probably that students fall into. There's a middle term. So let's just show this real quick and then we'll go to example 1. So the middle term is quite important. You cannot forget about the poor little middle term. So if we want to do x minus 1 times x minus 1, we do the first terms of foiling. So FO, so outside, invisible 1, and then FOIL, inside, and then last. So we get x squared minus 2x plus 1. You can't forget about that middle term. Please, I will be heartbroken if you do on an assessment in our class, let alone the MCAS, the SATs, SAT2s. Just difference of squares, very important. It's like almost as important, maybe it's probably more important than the vertical and horizontal lines. That's another, classic trap. Let's see. First question, number 1. We're factoring negative y plus 28 equals y squared. So my advice is to solve the equation for 0. So there's my equation. I would advise you to set up this kind of little skeleton every single time. Y minus, because now you need in here 2 numbers that multiply to 28 and add, subtract to 3. This is the first problem, so let's show all of our, all the work. If I want to do 28, all right, 28 days in the month of February, 28, 2 and 14, 7 and 4. So 7 and 4, they subtract to 3, and 7 times 4 is 28. So we'll do 4, 7, and if I make this positive, if I were to check my work, because we're done, we factored completely, if we were to do y times y, That's y squared. And 7 times y, that's 7y, minus 4y, minus 28. There's our answer. We're back to where we started. So the answer factored completely is right here. Staring us right in the face, y plus 7 times y minus 4. Number 2. Attention. Okay, number 2. X squared minus 12x minus 45. Let's rewrite it. Okay, seems a little harder. I'm going to put in my skeleton here. X, X. I know everyone is more familiar with X, but it's good to be able to solve equations or factor expressions or whatever that don't have X's in them, like the last problem. 45. Ooh, gosh, who knows that off the top of their head? So 45. 1 and 45. 3, 15, and 5 and 9. Well, 15 minus 3 is 12, right? So if I say this is 15 and that's 3, then minus plus. Let's double check. So negative 15 plus 3 is negative 12. Check. 3 times negative 5 is negative 45. Check. Factor completely. That's f of x. Done. Next question. Okay. Okay, we're going to rewrite this, and we're going to solve for 0. Woo. Okay, that is getting annoying. So what's going on here? No. Okay, let's change the color. Let's see. So here we go. Okay, 5p squared minus 16p plus 15 is 4p minus 5. Let's again solve for 0. So a key thing here is to simplify whenever possible. So simplify by dividing by 5. What's 20 divided by 5 is 4. Now we can set up our skeleton with, okay, P for Patrick. That's why I chose it. So numbers that multiply to 4 and add to negative 4, minus 2, minus 2. So it says now solve. So we're going to take the left-hand term, the left-hand factor, set it equal to 0. Take the right-hand one, set it equal to 0. So we get P is 2 and P is 2. Coincidentally, if you were asked to graph this, tangent to the x-axis at 2, and the y-intercept is 20. Might be good to know that. Okay, I don't know about you, but I'm ready for a challenging problem. This next problem is tricky. It would appear to be a straightforward problem, but it gets a little bit harder. So let's rewrite it. Okay, so factor out an x. So if I do that, okay, so I want to point out a couple things. So the factoring out of an x, that's the same thing as x minus 0. I want to make sure everyone knows that, because the x represents a, if you were to ask to solve, that would be an x-intercept at 0. This graph is going to go through the origin. Very important. So now let's set up our grid here. So 2x and x. Well, let's see. I need two numbers to multiply to a positive, but then they have to add to a negative. So if we were to say, so I'm going to be maybe doing a little guessing and checking here. If I do 1 and 3 minus, let's see, negative 3 times 3 is 3. Negative 3 minus 2 is negative 5. Done. So what does it say to do? Factor completely? Done. It's a tough problem, guys. Okay. So we'll pause right here. Any questions? Put them on the video summarizer. Bring them into class. But the questions you've been putting on the video summarizer have been great. Okay, next one, 5. We're making a move here. 5. Again, this is, you want to factor out an x, but I'm going to rewrite it so you can see it more clearly. So I'm going to factor out an x, and let's see. X. Oh, this might be our little friend difference of squares. So difference of squares, very important to recognize. So difference of squares. So difference of squares, this is x 3x squared minus 2 squared. So the difference of squares is going to be 3x minus 2, 3x plus 2. Done. Okay. Moving right along. Almost done. All done. Okay, so find the sum of the roots of. Okay. We'll be doing in class. We may be doing problems when you actually have to find the sum or the product of the roots. Let's do it the long way. Let's factor this, and in class we'll expand on this more. So we're looking for two numbers that multiply to negative 20 and add to negative 1. Well, I think 4 and 5 should be staring us in the face. Minus plus. So those are actually not the roots. The actual roots, let's set this equal to 0. The roots are negative 4 and 5. If I wanted to do a rough sketch of this parabola, there's negative 4. Again, I said rough sketch, right? Rough. The vertex is wrong. The y-intercept I'm not even labeling, but I know it is facing up. But the sum of the roots, negative 4 plus 5 is 1. All right. We good? Last question. Okay, so the last question is going to seem a little bit hard. All right. Let's just get right to it. Sum of two numbers is root 48. Let's call them x and y because that's what most people are most comfortable with, including myself. The next one, their product is 4. So this was given information. Probably is going to be important. It says, find the sum of the squares of these numbers. Okay. Remember the perfect square trinomials thing that I said was the biggest trap in high school? Well, this equals x squared plus 2xy plus y squared. Now let's highlight what the question is asking us to do. Sum of the squares. Well, here's one square, here's the other square. You add them together, you're going to get your answer. And you know what x plus y is. Well, that's root 48 squared. Excuse me, does that make sense? It does, yeah, right. So you know the square root of a number, if you square it, they undo each other. So 48 x squared plus y squared plus 8. Ba ba ba. Fa fa fa. So now I'm going to subtract 48 and 8 and get 40. And that is the sum of the squares. Yay! Okay. So the answer for the last one, number 7, is 40. That is factoring quadratics and we talked about difference of squares. This last sort of difficult problem talked about perfect square trinomials. We will talk more in class on sum and product of roots. But the key objective was to factor quadratic equations or expressions, and we just did that about 7 times, or maybe 6 times. So thank you for listening. I will see you next time. And if it's like 11:30, gosh, if it's like 11:30 p.m. or later, you really should be asleep. Hopefully, I've been asleep for several hours. But just a little tip. I hope you're having a great day or night. Okay, bye bye.